Okay, Mr. Phelps is going to be gone today, but he's going to try to make sure you don't get too behind here. So you're going to take some notes from the board in a second, but before you take those notes from the board, you're going to put them on a sheet of paper. Those notes, you're going to keep adding more to them. So find a blank sheet of paper, you're going to put those notes on the board. Before you do that, I want to go over what we're going to be talking about here. We're going to be talking about gas laws. Gas laws are going to have some variables. The variables we're looking at are pressure, volume, temperature, and number of moles. So for pressure, that we're just talking about if you're adding pressure to something, pushing on it. That's what we're talking about with pressure. Volume, we can just make it bigger or smaller, so we're going to change its size. Temperature, we can just heat up a gas. Number of moles. Moles, we can have 2 moles in there, or we can increase the number of moles to 4 moles. So these are the variables, and these are the things we're going to choose. Now, for our equations, we have the equations that involve the variables. You're going to write these in a second, but I'm just going to talk about them. We have Boyle's, Charles, and Gay-Lussac. Boyle's law is going to involve pressure and volume. Charles is volume and temperature, and Gay-Lussac is pressure and temperature. Now, notice how the equations are set up. The way they're set up, this makes Boyle's indirect, and the other two are direct. So what does that mean if it's indirect? Well, it means indirect means it's going to do the opposite. So if pressure goes up, the volume will go down. It's an indirect relationship. For the other two, it's going to be direct. So if volume goes up, the temperature must go up. Temperature goes up, pressure must go up. They are direct relationships. So let's see how we can use those on some problems you're going to be working. So I got some examples of what you're going to be doing. So here's our sheet. The first question is just identifying which law will you use. So the first law says volume and temperature while pressure is constant. Well, if pressure is constant, it's not changing, so we don't care about that. So we're looking for a law that uses just V and T. So we come up here, which law uses just V and T? That would be the Charles law. So the answer for this would be Charles. Okay. Then we might have some with some numbers in there. It says the volume changed. Okay, and I like to write V above that. And the temperature changed. So we're talking about temperature. So we're saying which law has volume and temperature in it. So see, I don't care about the numbers. I'm just looking for the variables V and T. So V and T would be a Charles law again. All right. So we have to identify the laws. Now let's find out what's going to happen here. If the temperature of the balloons, we're talking about temperature of a balloon increases, it says the volume remains constant. So we don't care about volume, the pressure will. So we're talking about pressure. So we're talking about P's and T's. P's and T's is going to be a Gay-Lussac. So I'm just going to put the GL there. Now, I don't want a number answer. I just want to tell me what's going to happen. Well, it says the balloon increases. For Gay-Lussac, it says it is direct. So if one goes up, the other also goes up. And so for the Gay-Lussac, if we're using pressure and temperature, it's going to be a direct relationship. So if the temperature increases, the pressure will also increase. Why? Because it is direct. Okay. The next one is a volume of a gas in a container increases. The pressure will. So now we've got V and P. Well, V and P is a Boyle's. Boyle says indirect. Okay, so if the volume increased, that means the pressure must what? It must decrease. Why? Because it is an indirect. Simple. For number 4, the temperature of a gas in a sealed container is tripled. The pressure will. So the temperature of a gas in a sealed container is tripled. So we're talking about temperature and pressure. Temperature and pressure is going to be a Gay-Lussac. So it's
Here or not here?
for Gay-Lussac, we have pressure and temperature, so that is direct. And so it says that if the temperature is being tripled and is direct, well, if temperature is tripled, that means the pressure is also going to be tripled, because it is directly related. The pressure on the container is tripled, so we've got pressure, and we have volume. Pressure and volume is going to be a Boyle's. It's indirect, okay? Indirect. So if the pressure is tripled, what's the opposite of tripling something? Dividing it by 3. So it's going to go down by a third. So that's how you're going to work your problems. So you're going to work those problems and turn this sheet into the box. After you get done with that sheet, then we're going to do some gas law problems, but these aren't gas law problems. This is just a math sheet. Notice what I have here. I just have the variables. You're just going to solve for the variables using your math skills. Yes, I have the answers on the bottom, so the only way to get credit is for you to show your work. So you need to go through and find the variables. For these, you're going to cross multiply and divide. These, obviously, you just multiply these and then divide by the 780. So we're just wanting to see, again, this is a cross, multiply, and divide. So just getting you practice on working the math problems.